Hey there, ever looked at a big 4-mark question and wondered where to even start? Well, you're in the right place. Today, we're going to crack the code on a classic chemistry question. We'll be using the official mark scheme to see exactly what the examiners want, so you can walk into your next exam feeling like you've got this. Let's jump right in. All right, so here's the beast. The question asks you to describe a method. Basically, how would you figure out where an unknown metal fits in the reactivity series? And look at that key phrase. Your method should give valid results. That's a huge clue. 4 whole marks are on the table here, and trust me, by the end of this, we're going to figure out how to grab every single one. Okay, so here's our game plan. We'll quickly look at the challenge again, then dive into what the examiner is really looking for. After that, we'll run through a few different ways to answer this, like using temperature or displacement, check out some other cool methods, and finally, nail down the absolute key to getting those valid results. Sound good? Let's go.
So let's just make sure we're all on the same page. The challenge is simple. Describe a method to place an unknown metal in the reactivity series. It's all about designing a solid experiment.
Okay. This is where the magic happens. Think of the mark scheme less as a grading tool and more like, well, like a cheat sheet. It's literally the examiner's checklist telling us exactly what they need to see to give you full marks. So what are they really looking for?
And here it is, the secret recipe. It breaks down into 4 core things you have to hit. 1, you need to describe a good method. 2, you gotta say what you'll measure or observe. 3, explain how your results will actually rank the metals. And 4, this is the one everyone forgets, you have to mention a control variable to make it a fair test. Nail all 4, you get all 4 marks. Simple as that.
All right, let's look at our first approach. This one's all about temperature. It's a neat idea, really. The more reactive a metal is, the more heat the reaction gives off. So how does it work? It's actually pretty simple. First, you add your unknown metal to something like copper sulfate solution. That's your method. Next, you measure the temperature change. That's your measurement. And finally, you put the metals in order based on that change. The bigger the temperature jump, the more reactive the metal. Boom, boom, boom. That's 3 marks already in the bag.
So we've got the method, the measurement, and the conclusion. We're almost there. But what's that final piece of the puzzle? Remember that 4-point checklist? What was that last, absolutely crucial thing we need to mention to make sure our experiment is actually valid?
You guessed it, the control variable. To make it a fair test, you have to keep something consistent every time you run the experiment. And the mark scheme gives you a bunch of options. You could say you'll use the same volume of solution, or the same concentration, or maybe the same mass of the metal, or even the same form, like using powder every time. The best part? You only need to name one of these to get the mark. Easy point. Okay, so what if you're not a fan of the temperature method? No problem. The mark scheme actually gives you other ways to tackle this. Let's look at approach number 2, using displacement. This is a classic. It's basically about seeing if one metal is tough enough to kick another one out of its solution. So for this one, you take your mystery metal and drop it into a few different salt solutions of other metals. You know, like zinc sulfate, iron sulfate, that kind of thing. Your observation is super simple. Does a reaction happen or not? You're just watching to see if a chemical change occurs. Then you just rank them. The most reactive metal will be the one that displaces the most other metals from their solutions. And here it comes again. You know what I'm going to say, right? That all-important 4th mark is for your control variable. And just like before, you've got options. You could mention keeping the volume or concentration of the solutions the same, or the initial temperature, or, yep, the same mass or form of the metal you're adding. Just pick one, write it down, and that 4th mark is all yours. You know, the mark scheme is actually pretty cool because it doesn't just stop there. It gives a couple of other valid ways to get the marks. Let's quickly look at 2 more, using acids and using electrochemical cells. So the acid method is pretty intuitive. You just add all your metals to an acid. The more reactive ones are going to react way more vigorously, right? You could measure the temperature change or even just compare how quickly they fizz. Then you rank them based on how fast they react. And for your control, you guessed it. Same concentration of acid, same volume, or same mass of metal. Now, this one is a little more next level, but it's an amazing answer if you can pull it off. You can actually build tiny batteries or electrochemical cells using your unknown metal paired with the others. Then you just measure the voltage. Here's the cool part. The bigger the reactivity difference between the 2 metals, the higher the voltage. So you just rank them by voltage. Your control here would be something like using the same electrolyte every time. So we've just walked through 4 totally different but completely valid ways to answer this question. But did you spot the one thing that every single one of them had in common? The one non-negotiable part you needed for that final crucial mark? It's this right here, this exact phrase, a control variable to give a valid result. This is the golden ticket. If you don't mention a specific, relevant control, you physically cannot get full marks. It's what separates a good answer from a perfect one, because it shows you know how to do real, proper science. So when it all comes down to it, here's the formula for success. It's this simple. Method plus measurement plus conclusion plus that all-important control. That equals full marks every time. Remember that simple equation, and you've totally cracked the code for these kinds of questions. You got this.